Welcome to the program. I'm Jeff Schechtman. When Hal asked astronaut David Bowman to open the pod bay doors, it was as if our most primal fears of machines came rushing headlong into the 20th century. Today, in our 21st century world, we understand the algorithms and even the artificial intelligence behind Hal. Add to this, on this very day, our understanding of the reliance on automation and AI and algorithms in flying our planes and our self-driving cars. It is the full blossoming of a brave new world. But is there anything that we should or could do about it? What better can we understand? And is any of it out of control? Or do we need to just surrender to the algorithm? Joining me to talk about this, I'm joined by our guest, Kartik Hosangar. Kartik is the John C. Howard Professor of Technology and Digital Business and a Professor of Marketing at the Wharton School. He is a co-founder of 4 different ventures, and his writing has appeared in Wired, Forbes, and the Harvard Business Review. He is co-host of the SiriusXM show The Digital Hour and earned his Ph.D. in Management Science and Information Systems at Carnegie Mellon. It is my pleasure to welcome Kartik Hosangar to talk about his new book, A Human's Guide to Machine Intelligence, How Algorithms Are Shaping Our Lives and What We Can Do About It. Kartik, thanks so much for joining us.
Jeff, thanks for having me.
It's a delight to have you here. When we think about algorithms, we think about them in kind of these scientific terms that somehow they are neutral in so many respects. But as you point out, did any of them that are created reflect the biases and the inherent proclivities both of the individuals or individuals creating them and of society?
That's right. I mean, I think a lot of people, algorithms, and machines in general, with being objective, rational decision-making engines. And in many ways they are. But also we're starting to see many examples where these algorithms are prone to the kinds of biases and limitations that we see in human decision-making. For example, there was a study done by ProPublica in 2016 about some of the algorithms used in courtrooms in Florida. And they found that these algorithms were being used by judges and parole officers to make sentencing and parole decisions, because these algorithms essentially predicted the likelihood that a criminal will reoffend and would guide these decision makers on what kinds of sentences to give to defendants. It turns out from their study they found that the algorithm had a race bias, that it was twice as likely to mislabel a black defendant as being likely to commit a crime. Late last year, there were examples of resume screening algorithms having a gender bias. And so now we're starting to see that these algorithms also have some of the same kinds of limitations that we sometimes see in human beings. And so clearly they provide a lot of value, and we should use them. But I think we also need some checks and balances in place, because they are prone to biases and misjudgments as well.
I guess the broader question is there a way to really tease that out of the algorithm? Can we create algorithms that are not biased?
Yeah, so I think that's an interesting question. To tease out the bias, we need to understand where that bias is coming from. And there are many ways in which these kinds of biases can come. But I think in terms of what people realized is that we can explain algorithm behavior in much the same ways as we explain human behavior. With human behavior, we think of nature and nurture as being 2 drivers of our actions and our behavior. Nature meaning our genetic code, and nurture meaning our environment, our friends, and our other influences. And algorithms are similar. They have nature and nurture as well. Nature is essentially their code, the logic that a human programmer puts into the algorithm. Nurture is the data from which they learn. And it's highly unlikely that when we talk about biases that an engineer is coding in those biases. It's not like there's a line of code that says if gender is female, then don't invite them for a job interview. It's actually often in the nurture, because increasingly we're moving towards algorithms that are learning more and more from data. So, for example, what we might do is we wanted to create an algorithm to drive a car. We might, instead of writing every rule in the algorithm, we might use a data set which has, thousands of people driving, videos of thousands of people driving, and we might have the system learn the patterns in there. So it looks at the videos and it learns when to brake, when to change lanes, and so on. If we want to screen job applications, we again have data on hundreds of thousands of people who might have applied for a job at an organization, who was interviewed, who actually got the job, who was promoted at the workplace, and we say, learn from this data. And now what happens is if there's biases in the data, the algorithm picks it up. So if there was a gender bias in the organization and women were less likely to get the jobs or less likely to get promoted, the algorithm learns that and almost institutionalizes that bias. And that's where the problem comes in. And that's why I like to say sometimes when we see rogue algorithmic behavior, I kind of say that it's kind of because our algorithms are hanging out with the wrong data.
When we create larger and larger and larger data sets, is that a way to get by this problem?
Well, having more data is clearly helpful in an era algorithms are learning from data, because more data implies that we're going to more likely see unique cases, and that we'll more likely learn that there are situations that are rarely encountered, but they come up. Data is helpful, but having more and more data alone will not solve these problems, like the kinds I mentioned, like gender bias, race bias, or, if we talk about, let's say, Facebook's newsfeed algorithm circulating fake news stories, some of that requires additional checks and balances. And engineers usually have, very direct measures and tests of the prediction accuracy of these algorithms, but rarely go beyond technical measures to socially important measures like, is the algorithm, is it biased in some way? Is it violating privacy in some way? So we need to think about auditing algorithms in a more holistic way.
You mentioned Facebook, for example, and that's just one. But one of the things that we see that does is it creates, and you talk about this in the book, it creates these echo chambers.
Yes, and we have all witnessed this, and it did get a lot of airtime around the 2016 presidential elections, where a lot of people expressed this concern that, we're each essentially seeing more and more of the views that we already hold and not the other perspectives, and that's causing society to become more polarized. And one reason that was happening is that the algorithms try to personalize the media they curate for us, and they're trying to find for us more and more of the kinds of content that we already consume. And that puts us in an echo chamber. That makes it likely that we have seen other perspectives, and that makes it unlikely that we can appreciate other viewpoints, and that makes society more polarized. And so we need to make sure when algorithms are designed, we're not looking just for, is this content the user will engage with? We have to think about other measures, like is there a social contribution and what is the impact of this algorithm on society?
Is there a danger that the algorithms and the processes by which they work continue to become more and more complex, and therefore so much harder not only for people to understand, for the average person to understand, but they become complex even for the people that are creating them?
I think we're already at a point where algorithms are certainly getting so complex that the users cannot understand, but increasingly to a point where even the people creating them struggle with it. And let me mention a couple examples. There was the crash recently of the Ethiopian airline, and from the evidence that's emerging, it seems like it was a problem with the autopilot algorithm. And one of the things that's happening now is that these systems are so complex that highly trained pilots also don't know sometimes how to react fast enough when the algorithm fails. And they have been used to, for a long period of time, working in a setting where the algorithm takes complete control, and now they don't know how to take back control in some senses. But going back to the algorithms themselves, we are also moving towards a class of algorithms. For example, there's a type of machine learning algorithm known as neural nets, and these are modeled on the human brain, and they're very complex. And essentially what's happening in these algorithms is they take in lots of data and they learn how to make decisions like humans have made. But the engineer cannot explain why the decision was the way it was, because the engineer did not code the rules. The engineer just gave massive amounts of data, and the algorithm picked up the pattern. So why was a person denied the loan? Why did the algorithm suggest this person should get a higher sentencing than another person? The engineer might not even know that, because there's lots of data, and the algorithm is almost a black box even to the engineer. And so that becomes a problem, and that's why in the book I've argued for things like transparency as a way to address some of the challenges with highly opaque algorithms.
I mean, I guess the question is, how do you create transparency in a world that is getting so complex that, as you say, even the engineers that create them don't fully understand them?
Yeah, so I think transparency, we can discuss that concept in terms of who that transparency is for. And we could talk about transparency for end users and transparency for auditors differently. Transparency for end users actually is very basic. It's not like an end user wants to know the inner details of every algorithm we use. But we would actually benefit knowing what's going on at the high level. For example, what kinds of data are being used by the algorithms to make decisions. Even, for example, just knowing that an algorithm made the decision. Often we don't even know that. You apply for a loan and the loan was rejected, or you apply for a job and you did not get invited. Was an algorithm used? And secondly, what kinds of data did the algorithm use? Knowing, for example, that the algorithm not only used the data I provided in my job application, but it also looked at my social media posts. That's helpful information. Knowing what are some of the critical variables that the algorithm focuses on. For example, for credit approval, here are the 5 most important variables the algorithm looks at. Those kinds of explanations can be provided even today. Mm-hmm. Now, as far as auditors are concerned, that audit has to be more detailed than the end user. I have argued that companies should be having their algorithms audited, especially when they're deploying these algorithms in socially important settings. And that audit could be done by an internal team, but that team has to be independent of the team that developed the algorithm. And that will help ensure that, there is some level of audit done, and those audits will also look into things like explanations regarding decisions. Even though engineers cannot today explain decisions, there's a whole field of research in artificial intelligence known as interpretable machine learning or explainable AI, and it's focused on how do you get explanations out of black box systems. And I think there is hope for progress, and I think we should require firms to look more carefully into those kinds of explanations. Otherwise, we will lose control of transparency completely.
Are we looking at algorithms that, in fact, audit the other algorithms?
Absolutely. That's one of the areas I'm personally pushing forward, and I am working on research related to that. I am also advocating this to companies that, if the algorithms are constantly evolving with data, as they get more data, they become more sophisticated. It also means that, the audit process has to be somewhat continuous because the algorithm is constantly evolving as it gets more data. And such continuous audits will be hard and expensive for humans to accomplish. So you might need algorithms to monitor algorithms as well, and I think that will be part of the solution.
Is there a field that looks at the idea of programming into these algorithms a more human approach, that there is a way to create algorithms that reflect more humanity in a way, I suppose?
Well, today I'm going to say that there isn't one field that's focused on that. There are a few fields that are looking at related ideas, but not exactly what you're saying. So there's the whole area of human-computer interaction, which is looking at how do people use the technology and trying to modify the software or the machine interface so that it's based on how users actually use it in practice. But I think there's a greater need for a study of how humans and algorithms can work together, and that will include understanding not just the engineering details, but also understanding social sciences, understanding the psychology of decision makers, understanding what drives trust in these machines, understanding what are some socially important outcomes of interest so that we audit these algorithms against these socially important outcomes like fairness and so on. I think that field hasn't yet emerged. That's an area where I work, and it's at the intersection of multiple disciplines. But it is going to be extremely important as we roll out algorithms in more and more important settings going forward.
It really relates to this whole idea you touched on a moment ago of decision making and really how human decisions are made, how machine decisions are made, and how the two, as you say, can work together.
That's actually right. We have a whole field in psychology that's focused on human decisions called judgment and decision making. And I think we need to think about decision making with algorithms in a similar vein, especially keeping in mind that these algorithms are being deployed and used by humans and for humans. And so we need to bring in those perspectives into the design. We need to also not only make sure the design is informed by knowledge of the human users, but also correspondingly the knowledge of the design is suitably conveyed to human users. I think we have to figure out how to train users to use these systems better and help ensure the algorithm serves them better. Think of, for example, ads. Today in some places we'll see, we have this ability to click and say, don't show me ads like this. Or with music recommendations, we can say, hey, show me music like this, but don't show me music like that. And that's a way for us to give feedback. And I think we should think about our interactions with algorithms similarly in many other settings where, we don't eliminate the human from the loop completely. The goal is, I don't think, to be completely autonomous and completely eliminate humans. I think the goal is to figure out how do we complement the human and how do we make sure the human and the algorithm are working very efficiently together. And so that means keeping the human in the loop for the things where the human can be helpful.
And I guess the biggest, or one of the biggest obstacles to that is that human interaction is pretty constant. Humans aren't changing that much. But the algorithms, the way they're created, the technological side of it continues to change, continues to evolve, and trying to keep those things in sync seems to be the greatest challenge.
It's a big challenge. It's a big challenge for users. It's a big challenge for regulators. By the time we've caught up on our technology, that technology has evolved even further. And so it's a hard challenge. And I think, at some level, we need to make sure algorithm and technology literacy is part of school curriculum, and it's like sort of basic knowledge that people have, because we are going to use these systems so much that we have to understand them at a deeper level. And we can't be passive about it anymore because the consequences are very significant, whether we're talking about a democracy or, whether, and curating news stories for citizens, or we're talking about use by doctors in medicine or used in the courtroom and so on. So I think we have to rethink how we do education. We have to rethink how we do regulation, and firms also need to stand up and do a better job of auditing and taking responsibility as well.
Kartik Hosangar. His new book is A Human's Guide to Machine Intelligence, How Algorithms Are Shaping Our Lives and What We Can Do to Control Them. Kartik, I thank you so much for spending time with us.
Jeff, thanks for having me on your show.
Thank you.